Okay, we're going to look at systems of nonlinear equations in two variables. So we want to graph the following system in order to solve it, and then we'll use algebra. So looking at the first equation here, this is a circle with a center at 0, since the x does not have a number added or subtracted. This is moving me down 3, so it's going to, up 3, so it'll be at 0, 3, and my radius will be 2. So I'm going to go to 0, 3, 1, 2, 3. Radius is 2, so I'm going to go up, down, left, right, 2. And so I have my circle. Now the other equation is a line, because there's no powers or anything. And it has been shifted down 4, or you can say that the y-intercept is at -4. And then it has been reflected, or you could say that it has a negative slope. So we're going to go down 1, right 1, down 1, right 1. And so if I connect these together, you can actually tell the circle and the line, they don't intersect. So there is no solution. So now let's look algebraically at what that means. The system is set up more for, I'd say, substitution, because the second equation says y equals. So I'll be able to plug that in place of that y. So that will look like x squared plus, in place of that y, I'm going to put a negative x minus 4. The regular equation already had -3 squared equal to 4. So let's see what this looks like. I'll have an x squared. Inside here, this will be a negative x minus 7, but we need to square that quantity. So that means a negative x minus 7 times negative x minus 7. So we're going to end up, if you square that, we'll have an x squared plus 7x plus 7x, and then plus 49. And we have x squared equal to 4. So we're solving this equation, combining like terms, we'll have 2x squared plus 14x. Since it's a quadratic, I'm going to move my -4 over, and I'm going to have plus a 45 equal to 0. So this doesn't look like it will factor. So I'm going to use the quadratic formula, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Now I already know that there appears to be no solution, but I want to know algebraically what that looks like. And so if I plug in to this formula, I'm saying my a is 2, b is 14, and c is 45. And so this will be x equals -14 plus or minus the square root of 14 squared, which is 196, minus 4 times 2 times 45, all over 2 times 2. And so I can see that my problem actually is going to be right inside this radical, because if I multiply 45 is such a big number in there, 45 times 2 times 4, I'm going to get 360. So this is 196 minus 360, which will be a negative amount. So we're going to have the square root of a negative number, which means we're going to start talking about complex numbers and I. And so we know that there can be no solution. So just right here, because we're going to get that negative under the square root. Okay, let's look at part 2. Again, it wants us to graph first. So I'm looking at the first equation. This is actually a quadratic because I have the power 2, so it's a parabola. It's shifted to the left 3 and down 1. So left 3 spaces and then down 1. You can see there's my vertex, and there's no stretching going on, so it's just going to be left 1, up 1, right 1, up 1. So I'm going to have this picture here. The second equation is again a line, has a y-intercept of 5, or it has been shifted up 5, and it has a slope of 2, or it's been stretched by 2, so it'll go up 2 spaces over 1, down 2 spaces over 1, and so we're getting, my line is not straight. Maybe I should try a little bit more. Down 2 over 1, down 2 over 1. It looks like it's getting a little bit straighter. But you can see it's kind of hard to tell with the graph, but I can see that there's two places where it is intersecting. And so the elimination or substitution will be really helpful. Again, I think I might want to use substitution because it has the nice y equals. And so what that will look like then is plugging that 2x plus 5 in place of the y. So we'll get 2x plus 5 equals x plus 3 squared minus 1. And so to solve that equation, I'll have to again square the binomial. So x plus 3 times x plus 3, and we're going to get x squared plus 6x plus 9 here. We still have the minus 1, and we have 2x plus 5. I'll want to put this all equal to 0 because it's a quadratic. So I'm going to minus the 2x, also minus the 5. So we're going to get 0 equals, it'll be x squared plus 4x. And then over here I had 9 minus 1, which was 8. And then minus the 5. 8 minus 5 is going to be 3. Now this quadratic will factor. It'll be x plus 3, x plus 1. And that tells me that x will be a negative 3 and a negative 1. So if I go back to my picture, that sounds about right. It's nice to kind of do the algebra and also the graph so we can verify this. So that it looks like it has x coordinate of negative 3, and this one could look like it has x value of negative 1. So I found my solution. All right, for number 3, it just says algebraically, so I don't have to graph these things. And actually it's set up nicely for elimination. So I'm going to try and eliminate my x squared. So I will multiply the second equation by negative 2. That will be negative 2x squared minus 8y squared equals negative 16. And I'm going to combine that with equation 1 up there. I'll rewrite it so we don't lose anything. So it looks like the x squareds cancel like we wanted. We're going to get negative 5y squared equals negative 5. Divide by negative 5, and so we get y squared equals 1. We'll square root both sides, so y equals both plus and minus 1. So we're getting two answers right here for our y values. So now we need to plug each y value in to find x. So we could plug into, let's just plug into the top one. So if y equals 1, we're going to have 2x squared plus 3 times 1 squared equals 11. That's 2x squared plus 1 squared is 1 times 3 is 3 equals 11 minus 3. We get 2x squared equals 8. Divide by 2, x squared equals 4. So then if you square root, then we're going to get x equals both plus and minus 2. So again, if y was 1, we're getting two answers. So that's a positive 2 gets me that y value of 1, and a negative 2 gets me the y value of 1. So I have two answers so far. Now I also need to plug in, just like I plugged in positive 1, I need to talk about the negative 1. So if y equals negative 1, let's see what happens. Again, let's plug in to the first equation. That's 2x squared plus 3 times negative 1 squared equals 11. When you square that negative 1, we're still going to get a positive 1. So together those will make 3. And this looks like we just did a moment ago. Minus the 3, we get 2x squared equals 8. Divide by 2, we get x squared equals 4. We square root, and so we get x equals both plus and minus 2. So that means that if y is negative 1, that came from a 2, or if y was negative 1, it came from negative 2. And so we actually have 4 answers here. There's 4 points where they intersect. And if you think about the graphs of these things, I'm not going to graph them full out, but you have x squareds and y squareds, x squareds and y squareds, and positive stuff. So these are going to be ellipses. So if you think about the way ellipses could work, they would have 4 points of intersection. There are other things that could work, like perhaps if they were only touching each other just a little bit, or maybe not at all. There could be no solution. There could be 2, none. In this case, we have that 4-pack. Okay, let's look at number 5. Again, it says algebraically. This one looks like it's set up for substitution, so I'm going to take the 4x plus 5 and plug it in for my y. That's going to look like 4x plus 5 equals x squared plus 4x plus 5. And so we have a quadratic equation. I want it equal to 0. So I'm going to move the 4x and the 5 over. 4x and the 5 over. So I'm going to get 0 equals x squared. And everything canceled. So we really have x squared equals 0. So that would just mean that x is equal to 0. So then we can find y by plugging this into either the top one or the bottom one. So if I plug it into the top, that's going to be 0 squared plus 4 times 0 plus 5. So we're going to get y is equal to 5. So that would be the point 0, 5. All right, flipping over to the next page for number 5, it says find two numbers whose sum is 12. So let's say the numbers are x and y. So if I sum them, they have to make a 12, and their product is 35. So x, y equals 35. You might be able to figure this out just off the top of your head, but let's do it algebraically. So right now it looks like it's set up maybe more for substitution, kind of. The first equation, I can make it so that way it's just x equals something, so x equals 12 minus y. So then I can substitute that in for my x. So that will be 12 minus y times y equals 35, which if I distribute, that's 12y minus y squared equals 35. Now I like my y's to be positive, so I'm going to move all this over to the other side to make it equal to 0. So I'm going to have 0 equals y squared minus 12y plus 35. So we're going to get, by factoring, this will be, let's see, 7 and 5 make 35. They're both negative. That'll make a negative 12. So that means that y equals 7 and y equals 5. So now if y is the number 7, let's see what x would need to be. If y is 7, we're looking at x plus 7 equals 12. So then x is 5. If y was 5, again, plug that in here. We're looking at x plus 5 equals 12. Minus 5 minus 5, we get x equals 7. So it makes sense that once 7 gets you 5, 5 gets you 7. So the numbers that it was talking about are 7 and 5. All right, the rest of these are review. It just wants me to write the domain and range for this function. One of the easiest ways to do that is to graph it. So I'm looking at it, I see absolute value is the basic function, so that's our V shape. 2 is stretching, minus 1 is moving us to the right 1 space, and the minus 3 is moving it down 3. So I'm going to be at 1, negative 3, do a little bit left 1, right 1. It's our basic structure, but actually we just doubled up, so left 1 up 2, right 1 up 2. That shows the stretch, which doesn't really impact the domain and range, but that way we have a little bit more accurate sketch. So the domain, looking at the graph, it goes forever left and right. We could also look at the actual equation, and there's no restrictions. We can plug in anything we want for the x value there. Now the range, because the absolute value is only popping out negative or positive numbers, but because we're minusing 3, the lowest we're going to be able to go is negative 3. And we actually do touch there, so it's a closed bracket, and we'll be up to infinity. So for number 7, we have a natural log. So when I see natural log, I know that that's the inverse of my exponential function. My exponential function kind of shoots up like that. We have e to the x. So I know that the natural log function goes kind of the other way over that line, y equals x. I also remember that you can only take natural log of positive stuff. So I know that right here, when it has that minus 3 inside, it's moving everything to the right 3 spaces. So the vertical asymptote that is normally there on log is now going to be at 3. And so we have this shifted graph, and the x values then are going to be from 3 to infinity. That's our domain. And our range, we're going to have all outputs from negative infinity up to infinity. For number 8, it wants us to just use the graph to solve. And so what they have done for us is actually graphed the left side and the right side of each of these. And they're both lines. So if they want to know when they're equal, well, let's look. They're equal when they intersect. That's happening when x is equal to 2. It's the x value of 2. And then it wants to know, well, when is x minus 1, which is the red line, less than 2x minus 3? Or when are those outputs less? Well, you can see visually that the red line is below at this point as soon as we get bigger than 2. And so then that would be happening from 2, let me get rid of that, happening from 2 to infinity. Then I want to know, well, when is it that x minus 1 is bigger than or equal to 2x minus 3? And that's happening on that section right below, or less than 2, because all of this is sitting right up above. And so for that one, though, we're going to include 2 because it said or equal to, which they're equal right there. So then that's going to be everything from negative infinity all the way up to 2. If you want to see it on the number, on the actual x-axis, we're talking about all of this section right here from negative infinity over to 2.